this video, we'll be discussing heart disease prediction using machine learning. Heart disease prediction has been a very trivial and uh, researched problem in the medical domain. It has been existing since ages, and still we are trying to find a very accurate and proper solution to predicting heart diseases. So basically, in this project, we have come up with a model which predicts if from the patient's details, from the given details, it predicts whether the patient is prone to heart disease or not. So the real-time use case which it involves is we can diagnose a patient immediately with processing his or her results into the model and getting the prediction out if he has a heart disease or not. So it would be a very efficient and quick way to recognize from the patient's reports itself about his heart condition. We can use it as a consultant or a assistant for a doctor. So basically, to cross check the results from the doctor's side, we can use this as a tool to support the doctors and the medical team. So this is the second use case which can be applied using this project. So let's talk about what happens in the existing scenario. So basically, in the current situation, the patient has to visit the doctor in person, take out the reports, give the reports for doctors, and get the doctor's assistance on the reports, and then he would be knowing the final outcome if he has a heart disease or not. So this process is a bit time consuming and rigorous for both the patient as well as the doctors. So basically, this poses as a problem in the existing system. Secondly, the accuracy with which the predictions are made. There are solutions existing in this domain which involves computers. So the solutions that involve computer, they do not provide up to the mark accuracy which is required in these cases. In medical problems, the accuracy part plays a very important role because we are playing with lives at the end of the day. So basically, achieving that level of accuracy is a bit tough and not very much visible in the solutions which have been existent. Thirdly, the parameter selection. Basically, if we need to get the report of the condition of the heart, we need to get to have a look at a certain parameters. So training the model on that parameters makes it more efficient. But in the existing solution, I guess the parameter selection may be varying as per the understanding of the person. So basically, someone might choose parameters which are not very crucial regarding in considering the heart, and some might choose other parameters as well. So basically, the parameter selection has to be accurate in order to predict heart disease. In the solution which we have proposed, we have used multiple models to train our and got it trained on the data, and this has been done to check which one achieves the maximum accuracy. So we are not doing any compromise with the accuracy part. Secondly, the parameter selection, we can see that the parameters which we have selected, we have in detail explained them also here. So the data set which we have chose for the this project is clearly described here in this section. We can see all the parameters that have been used. So I can read out some of the parameters like age, current smoker or not, then BP medicines take, what is the amount he is taking, he or her is taking. So these are the parameters, basically diabetes, cholesterol, etc. So On the basis of these parameters, we will be predicting at the end if the person is suffering from a heart disease or not. So basically, the parameter selection has been very much apt for this problem. Lastly, the time consuming part which we are reducing through this approach is a lot. Like the physical part which I told you before, we are cutting that part and giving you the outputs in minimal time. So you can see this is the data analysis part. We analyze the data for all the patients together and get an overview of how and how well the data is distributed. So this is the data analysis part. Lastly, we have the model building part where we use different models and try to compare them with among themselves. So we can see it here. We have clearly described each and every section in detail. So the models which we have used in this project are basically, first one is the logistic regression. It's a basic model coming on to classification problems. So we analyze the outputs from the logistic regression model and compare it with models like KNN, K nearest neighbors, then decision trees and support vector machines. Lastly, gradient boosted tree classifier. So out of these five models, we did a detailed comparison on how they work, how well they work. We had an overview of their precision, recall, F1 score, support for all of them, and then made a comparison and finally got to a result on which model should we use or which model is the best in this problem. So basically, we after the comparison, we got to know that the support vector machine provides us the best accuracy out of all the present models. So we finally can go forward with the model which was built using support vector machine. Support vector machine, it has advantages as it takes the data to a higher dimension. It is a specially designed model for regression, like classification problems. Sorry. So it works pretty much well comparatively to other classification models. So this is the overall explanation of this project. Thank you for your patience.